all, how did you guys determine the volume of the galena?
Water displacement.
Water displacement, and then you determine the mass. And what did you come up with for your density of galena?
6 and 1/100 grams per milliliter.
Okay,
And that was with this bigger, shinier one.
Yes, but there was two different ones, and they were one was slightly bigger than the other.
okay. Does density depend on size?
No, but it's gonna
No.
change the mass, which can alter the number.
Because
So
this
if I
isn't the
had-
same.
If I had a
They're
block
not
of
the same mass.
galena, so, but they weren't the same volume then?
Yeah, that's what I'm saying.
Yeah.
So
So
other
the
people's
density
numbers might.
shouldn't change. Density of a truckload of
okay.
galena is the same as the
Okay.
density of a little plug of galena. Galena's galena. Okay, what did you guys get?
7 and 100 grams per milliliter.
Okay, let me get this down. So what?
Same one. Same volume.
And what was yours, Brenda?
7 and 100 of a gram per milliliter.
How about y'all?
We didn't get that far.
You didn't get there, okay. Craig?
What is going?
No, we're doing the silver one. Oh, wait, where are we doing?
Yeah, the shiny, really shiny one, right?
Yes.
Seven and
Oh, where's it? 7.3?
7 and 3/10.
7.3.
7 and 3/10. Okay. Brenda?
We didn't get to that one.
Okay. Candace?
We got
7 and 3/10? Okay. So it's somewhere in this range then, okay? So the second one, what was yours, Brenda? Ashley, Melissa?
Pyrite.
Okay. And what was your measurement?
For the density,
Well, yes, what was your calculation for
5
that?
and 3/10 grams per milliliter.
5 and 3/10 grams per milliliter. Did anybody get anything way different than that?
Couple different, couple points off.
And pyrite?
6 and 9 then.
Ooh.
Grams per milliliter.
Okay,
Yeah,
guys,
We
but
had 3.5.
listen, please.
I broke it. I actually just broke it though.
Okay,
I
other
actually,
pyrite calculations.
We got 4 and 4/10
I broke it.
grams
Okay.
per
It
milliliter.
doesn't matter though.
Oh, okay.
3.5.
3.5, goodness gracious.
Use the same for both measurements.
Elizabeth,
Please listen, please listen. Candace, what did y'all get?
Pyrite or 6 and 8/10.
6 and 8/10. Okay, so we've got some, a wide range, okay? Let's throw out the top and the bottom and average the rest. Got that? Okay, the next object, we've got the golden.
The brass prism rectangle.
Yes, let's call that brass.
9.3.
Okay, we need to move through this. Brass, what did y'all get?
11 and 1/10 grams per centimeter cube.
Why centimeter cubed, Clinton?
Because it was in millimeters and I didn't feel like keeping it in millimeters, I converted it.
But why not milliliters?
Because we were able to use the ruler to measure the object rather than using volume displacement to find the volume.
Okay, good, thank you. Okay, so anything vastly different?
Oh, 9.39? Oh, that's fast.
Yeah.
Yeah, I think
9 is 9.3 repeat or 9 1/3.
Okay. So,
Did I do it?
now, when, those of y'all who got 9
She
something,
got 9 as well though, and we used the same stuff, so I must have done the math wrong.
okay,
I'll check.
all right, let's leave it like that. Okay,
Station
what's
4.
another one? Copper.
9.4.
inches for the brass.
Yeah, we did.
We got 13 for A2.
Well, it depends on which.
It depends on which piece you use.
No, it doesn't matter. Shouldn't,
We're
it
talking
doesn't
about the
matter.
brass.
Or the brass, the brass.
Quentin, would y'all, somebody right there hold up the brass rectangular prism,
That one.
thank you, that's it. Okay, now the copper, let's,
Do they measure in inches or centimeters? For
The brass.
the brass?
Always centimeters.
Because if they measured in inches, it'll be a different.
did you
That's
measure
fine.
in inches?
We did millimeters.
Okay. Okay, the next one, let's go back here. What did y'all have, Elizabeth?
I'm sorry, for
What,
which?
what did you have? What was your object?
Oh, the, cube, the silver doll. I don't know which one.
Okay, the silver cube, what did you get the density of the silver cube to be? What did you calculate the density of that silvery cube to be?
2.6?
Yeah, but there's two silver cubes.
Yeah, but they're on the same page.
Okay, anybody get anything vastly different? Yes. 2.76. 2.76?
Oh.
Okay. How about the nail?
You got something more different.
0.7,
0.7? What?
0.7 grams.
That's like water.
Mass 2.0.
Mass, 0.7.
No, we're
I'm not
doing
talking about the mass, I'm
density.
talking about the
2.3.
density of the.
The density, 2.33.
What did you get?
Repeat it.
Grams.
Okay, milliliter.
Milliliter.
Okay, nail densities, anything different than this?
Yeah. What? 1 in 6,700.
Shoot. My heavens,
That's insane.
it's big, okay, thank you. And the copper. Okay, first of all, we're just gonna say these out loud. Who used the copper tubing? Copper tubing, what was the density of the copper tubing?
6 and 2/10.
6 2/10.
7 and 75 alcohol.
Okay.
6 and 9500ths.
6 9500ths, okay. What about the native copper?
The cluster one?
Yeah.
8.3?
6, you said what?
8.31?
9 6/10. Who else used the native copper?
8.31?
8.31? 8.9, okay. And the copper wire? Nobody, okay, good. What might the difference be between the copper tubing, because the copper, the native copper was more dense, those numbers came out more dense than the copper tubing. Why do you think that might be the case?
The copper tubing could have another metal, like a lighter metal inside of it to
Okay.
improve some sort of feature. Use for the, like aluminum to make it lighter or more flexible.
Okay, that,
So it could have another metal inside.
okay, and what about this copper here? Could it have anything in it?
It could, I mean, it could have some impurities, but it's not as manufactured, so
Okay.
it'd probably be less likely
So you're talking about the purity of the
of the samples.
Okay, all right, good. That's important. Okay, good talk. All right, so we've looked at how that relative density works. We've looked at how the calculated density. So your measurements were your mass and your volume. Your calculation was the density. And we came up with some really interesting numbers. And so let's use these. If you don't have them, use this as the value that you did not obtain for yourself. And we're going to use that data to answer the questions on the next page. The object with the greatest density was the brass. The object that is the least dense,
The nail.
the nail. Okay? Yeah, the copper was, what was it, 9?
8.9.
8.9.
Or 8.96.
8-inch, okay.
For today, but I looked.
I have a question.
Okay, yes,
When you're comparing, the densities, and you have the grams per milliliter and grams per centimeters cubed, how are you, I guess my question is, how are you comparing using two different, units of measure?
well, that's a really good question, and I heard a discussion over here about centimeters cubed is what you would measure as solid objects, but milliliters is more of a volumetric measurement, but they're equivalent
Okay,
in volume.
okay.
So
makes sense.
that's a great question.
1 milliliter equals 1 cubic centimeter.
Yes.
Right.
Yes. Okay, now, what if we had, let's say that this copper, I'm sorry, I'm just reaching all in your business. Let's say that these copper pieces I'm holding are absolutely pure. They are exactly the same substance. I've got a teeny tiny little bit of wire, but I've got a big chunk of this copper. How does the size of the object affect its density?
It does not change the density of the copper. The copper is a constant.
Why?
Because there's the same compound, not compound, but element, whether it be in a wire form, because now you're just looking at the physical property of making it ductile.
So it only depends on the elements.
Yeah.
Okay, so
It's
let's.
not an alloy, in other words.
Okay, so let's think about this then. Let's take carbon, right? Carbon is a common element. It makes up a whole bunch of different things. But carbon in its pure form makes up some things in this room. What is something that is purely carbon in this room?
Graphite and pencil.
My diamond, your diamond, any diamond. It is pure carbon. Now, if you take that same carbon and you arrange it in a different way, and maybe those carbon atoms are bonded in a different way, then you can end up with the graphite that is in your pencil. Now, while I haven't measured the mass and the volume of my diamond, or the mass and the volume of my graphite in my pencil, I know that the density of the diamond is greater than the density of my graphite. Would you agree?
Yes.
Okay. Still carbon though. So we have to be careful about saying that it is just the element, because that's not the only factor.
Well, but again, you know, you gave me restrictions of what I was comparing. You didn't say, well, let's look at the volume of the copper, and we're going to also compare it to a diamond.
No,
You know, we
you're right.
we know that that carbon has various molecular shapes, and thus when it changes shape, just like water, we can change the shape of water molecularly by freezing it. That's why ice floats, because water expands as it freezes, and that becomes less dense than liquid water.
Right, but it's the structure that changed.
Right.
Right.
Yeah.
So that's what I'm saying though, is that in that copper, the size doesn't matter because it's still the copper, not just because it's made out of a copper atom,
No, I understand.
but it's still structurally the same.
Yeah,
Right.
but it's not yeah.
Okay, all right, I think we're good. Okay, we are going to stop for a break. For good.
Lunch.
Lunch break.
I have an offer for good.
But first,
And
now, I don't want you to say anything, I want you to think about it, because this is not easy. I want you to come up with 3 words, not sentences, not phrases, but 3 words, well, maybe it might be, no, I don't know, let's just say words, of best practices you saw today. So 3 words, okay? And then I want you to think about 3, it might not be words, it might be phrases, that you have a question about the pedagogy today. So would you write that down? So 3 best practices you saw today, in 3 areas of best practices that you have a question about or want some further discussion on?
They don't have to be phrases, right? I know.
That was a lunch stop.
Okay. Pay attention. In your notes. Three areas dedicated to issues of a question, conversation.
Dr. West, 3 words, and what was the last thing?
3 pages, you have a question about.
3 pedagogical areas that you might have a question about or you want some more discussion on. So
And
that might be
anything,
more
not
than
just
one.
related to just any.
What if,